Okay, so this is just a little video to try and help you with logic gates. So, logic gates. And the logic gates we're going to look at, the first one we're going to look at is an AND gate. So an AND gate looks like this. And it has two inputs there and an output, and it's got like a flat back to it, then a rounded bit to the symbol. And if we have a 0 and a 1 as an input on an AND gate, it's going to be 0 as an output. And the reason for that is that both of these inputs, i.e. input 1 and input 2, both have to be 1 in order for the output to be 1. So the only time on an AND gate when we're going to have a 1 as an output is when both of the inputs are 1. So both of those inputs are 1, and that one will then also be 1. So the other way around, if that's a 1 and that's a 0 on this one, it's still going to be a 0. And we can draw something called a truth table for that. Truth table. And the possible inputs are 0, 0, 0, 1, 1, 0, and 1, 1. And the AND output for that, two zeros, 0 and 0 is going to be 0, 0 and 1 is 0, 1 and 0 is 0, and two inputs as 1 are going to be a 1. So that's our truth table for AND. Now, the other gate that we might look at is OR. So an OR, so this gate is true when either or this input or this input is true. So that means the OR gate, it looks like this. So it's a different shape to AND, so we can tell the difference. So again, two inputs and an output. This time it's got this sort of concave type of back to it, this curved back, and it's more of a pointed arrow shape. So if input 1 is 0 and input 2 is a 1, then OR is correct. So either this one or this one is a 1 and the output is a 1. And obviously the same applies to 1 and 0. The output is going to be a 1. Draw another one. If both inputs are 1, then the output will be 1. Because OR still is the case, so it's either this one or this one. In this case it's both of them, and that's absolutely fine as well. But we might have an occasion where both inputs are 0, and if both inputs are 0, the output is 0. So the truth table for that would look like this. This is an OR table, and so the inputs are the same options. Because it's binary, we only have those options. So 0 or 0 is going to be 0, because anytime there's a 0 in there, it's going to be two noughts. It's going to be 0 as an output. Then we've got 0 and 1. Well, that's a 1 because that one is the 1. 1 and 0, that's a 1, and 1 and 1 is a 1. So you might see that actually the truth table for OR is pretty much there, opposite to how the AND is. So AND's got 3 noughts and a 1, so there's only one scenario there where we get a 1 out of AND. OR only has 1 nought and 3 ones, so there are 3 scenarios where we get a 1 out of an OR gate. Final gate that you might look at is a NOT gate. So NOT is sometimes called an inverter. So if this input is a 1, the output is a 0. But if this input is a 0, the output is a 1. So it just reverses the input. And you can see there's only one input to a NOT gate. One input, one output. NOTs are drawn like this with a triangle and a little round circle on the end. Don't forget the round circle when you get to GCSE particularly, you have to put that round circle in. So the truth table for not, well, the possible inputs are 1 or 0 because there's only one input this time, and the outputs are going to be opposite. So the truth table for not is very simple like this. So that's the basics of logic gates, simple logic gates, just one gate and the truth tables.